To get this class started, I thought we'd do a little bit of the history of manufacturing, see where our roots lie. So what we're going to do is look at the need for manufacturing, and it's based on money, of course. Do a quick history of it, and look at some of the key people in manufacturing where they changed the ideas, and give an example of a process. Again, it's about money, right? So manufacturing, we're making stuff that people want. So about 20% of the American GDP is coming from factories. It's about 17% of everybody in the workforce works in the factories. And that means about 80% is a service economy. And as you look at the pandemic, the different countries that have a higher percentage of GDP come from manufacturing are faring much better than the service centered economies, China, India. So manufacturing is important, and it's actually going to keep us afloat during the pandemic. Now, manufacturing has been going on for a long time. You know, they've ever since Homo erectus chipped his first piece of flint, or even chimpanzees will do some forms of manufacturing to make tools to catch termites. But they're all handcrafted, right? And one at a time, handcrafted. There's one really big example that's stuck out like a sore thumb. It's the Venetian arsenal, and this came out about the 1200s or so. And what they did is they just dedicated about 110 acres to making warships, right? And they developed a new technique, right? It's called frame first system, and they could pump out one of these boats every day, which is incredible. And that's why they became a big Navy superpower. They make some other things. So they improved on muskets and things like that. It's still in business today. It's 950 years of the same factory, same location. One time it had 1,600 employees in the 1500s. So it's a big deal. Again, most people prior to the 1800s, it was all handcrafted. Everything was crafted, so which is all right. I mean, you had the guilds and stuff, and they were very good. Some of the products, but they were all unique. Even the same, looks like the same gun, but it's not the same gun. Every one is unique because they're all handcrafted. They still do this sometimes today. I'm thinking like craft beers and things like that. They say they had a better quality. We'll talk about that later, about what quality is in later classes. But this is the way they did it, and some people still do it that way, one at a time, crafting everything. Okay, this is the metal part of a musket, and if you look at this, prior to about 1800s, if you had a musket made, it would only fit in that one stock, all this metal bits. And if a frizzen spring broke, well, guess what? You had to go have a custom-made frizzen spring because each frizzen spring was custom fit to each frizzen. The parts just worked on that one gun. So if something broke, you were basically screwed, right? Imagine battle, you got your musket, and all of a sudden something like the hammer will break or something like that. You're pretty much left with a pointy stick for a weapon. Well, there's a gunsmith in France named Blanc. Well, he says, well, look, if we have interchangeable parts, in other words, if I had a broken frizzen pin, I could just get a brand new frizzen pin and replace the broken one, and it'd work in any gun, any musket, right? So he's in France. Jefferson's over there as the ambassador. Well, he tells Jefferson about this. Meanwhile, in America, Eli Whitney's there, and he's invented the cotton gin. Went bankrupt, actually. But he went up north to make his money again. So Jefferson comes back and tells Eli Whitney, by the way, that's Eli Whitney's picture, and says, hey, I got this idea from a Frenchman. It's called interchangeable parts. And the United States Army needed some muskets, big time. That was the part that was holding our army back. So Eli Whitney says, well, here, let me do it. So what he did is he invented some machines, milling machines, and he started making interchangeable parts. And then he would break the assembling things down to smaller and smaller parts. So it took less and less skill for the person working there. It's huge, right? You no longer had to be a skilled craftsman to make a gun. And he also, what he did, he's a pretty good guy. He tried to treat his factory workers with respect and pay them well. He didn't get that idea, didn't catch on so much, but Eli Whitney, first American to use interchangeable parts. Well, this is Henry Ford. He stands for the assembly line. And what he did is he put the assembly in proper order. In other words, you had to do certain steps, right? And again, he tried to break down things into smaller parts, just like Whitney did, and have one guy like put on the lug nuts. That's all he's going to do, right? And he's always thinking. I was up in Kingsford, Michigan, and there's a foundry up there. Well, he had parts of the foundry come in these big wooden crates. Well, he had the wooden crates specified, and they had certain holes in the crates on the side, and nobody knew what they were for. But they said, well, I guess he has his reasons. We don't know. And what he'd do is he'd take those wooden crates, those pieces of plywood basically, and that was a floorboard for this Model T, right? But he had some trouble with his workers. Same thing. He never caught on to Whitney's idea of treating them with respect. There's one year, I think it was like 1911. There were 200 severed fingers in his factory, right? So he said, okay, enough of this. He goes, I'm going to go from more than about $2, $2.50 a day. I'm going to start paying people $5 a day. And in fact, that's why my ancestors came from Eastern Europe and settled in Michigan. Henry Ford brought them over there to work in these factories, right? And it's pretty cool. We got the price of this car down to about $300 per car, which is about 6 months' salary. Well, it used to be about 3 years you had to save up for a car. That's if you spend none of your salary. A little bit of trivia: the first human killed by a robot was in a Ford factory in 1979. He got hit by a robotic arm. This guy's name is Kiichiro Toyota. He's a big manufacturing guy. He had a lot of factories in Japan. After World War II, basically they didn't have any money. So what he did is he said, well, heck, we got to buy these engines. We can only buy like 2 at a time. So they'd come in literally on pickup trucks instead of these big shipments. And he started to make money with it. Well, they said, well, now we got enough money, we can use semis and stuff. But they put pen to paper, and they said, we're actually saving money because we don't have inventory, don't have handling costs. We're saving money by having these come in small lots. This is called just-in-time delivery. And he applied that to his own manufacturing. You don't get a Toyota. If you go to a Toyota parking lot or sales, you won't see a lot of cars on the lot. That's because Toyota doesn't make the car until there's a demand for it, right? You can go to an American car lot and just see how many cars are sitting on that lot, right? So if you go to Toyota and they don't have the car you want, they'll say, okay, you can get it in about 2 days, and they make it. You do that in an American car company. Let me see if somebody's got it on their car lot, and they'll ship it from that other car lot. So Toyota's big thing, and again, this is spelled a D, but this is actually Toyota, like the car. He came up with lean manufacturing, right, and a bunch of other things, Kaizen, good change, and things. We'll talk about that later. But this whole thing is about taking the cost out of manufacturing and quality, big time quality. Again, we'll talk about that later. And he didn't want anybody cutting their fingers off either. So he had safety. He also engaged the employees on improvement. A lot of radical ideas from Toyota. Well, in the 1950s, the Webb Company made an electronically coordinated conveyor system. And this is huge. For the first time, actually, machines are getting, I don't want to say smart, but they could work with humans, right? So the thing didn't move until it was needed. And it always kept the workers stocked. It kept the pace right. It didn't go too fast, didn't go too slow. It kept up with the human worker. Well, Ford was big on this, and he started using this. A tire would come in on a conveyor, one of these Webb conveyor belts, but it'd come in one at a time and only when it's needed, right? I also like this because if you go to um, Jonesboro, there's a couple really, really big conveyor factories there. You should see what they do there now. It's incredible, the technology and how fast these things can move and how coordinated they are. I know Hytro is working a little bit with Amazon. So is FMH, I think, to get some smart conveyor belts. If you ever bought anything from Amazon, right, and you put in the order, and about 10 minutes later it says, your order is packaged on its way or something like that. Amazon uses these automatic storage retrieval systems. And what they'll do is that you order something and no human even looks at it. It goes straight into this thing, this ASRS, and it'll go and it'll pick out whatever you ordered and it'll drag it over and give it to the guy that's going to pack it. They still not, the machines aren't very good at packing yet. They'll get there, I'm sure. And it's incredible. Less mistakes, faster, more reliable than human employees. And that's the way we're going now with the factories. Automation, right? A lot of automation. And the trouble with automation is, and before you didn't have a lot of flexibility in your manufacturing. The machines are getting there now. They're going to be there. A variation of this is the automated guided vehicles. You've got some big pieces. Well, they'll just set them on these vehicles, and you need it. And these things will drive over there all by themselves and deliver the piece to you, right? Artificial intelligence. Basically, they describe this as a machine will make a mistake. It'll learn, oops, don't want to do it that way again, and adjust itself, self-adjust itself. And what it'll do then is it'll make the perfect process. The last car I bought, I purposely chose it because I knew it was built by robots instead of humans. Much tighter tolerances, much more exact. If you look at Kia, there's about 1,500 people that work for Kia in the United States, and they make all the Kias you see on the road, all of them, right? Just 1,500 people, which is just incredible, just incredible. So if you start to talk about manufacturing, this is a big clue. You're not going to do it by being a craftsman or by making parts by hand. You're going to have to be able to work with machines and robots and understand them. Again, if you're going to be in a factory, you're going to have to be working with these computers and smart machines. It's called computer integrated manufacturing, and it's everywhere. I was up in Wisconsin working for a hydraulics factory. Had about 500 employees, and we were pumping out about $700 million worth of hydraulic product every year. I got hired on down at another hydraulics factory down in Searcy. 500 employees again, and we were pumping out $110 million a year. The one in Searcy went from about, the company as a whole went from about 75% market share to about 2.8% when they were bought out. The one up in Wisconsin, they didn't have a market share. They had about $6 million in sales every year. Now they own about 80% of the mobile hydraulic valve factory business market. And it's all done as computer integrated manufacturing. I'm going to give you an example. The cell that I was in, the company was Husco. The customer, and it was usually Caterpillar. Caterpillar would type in their order. It'd go into the computer. The software would spit out the shipping label. Well, and plus a list of all the valves we needed to ship that day. We would take that to out to the cell, and there you go. And it also, what would happen is, as soon as it did that, it'd generate the programs and things on the machines, the CNC machines, to make the parts needed to make those valves. And we reduced our lead time from about 8 weeks down to about 4 hours, right? And again, that company just rocked. I didn't realize how good they were until I saw how bad the other ones were. And this is what it's going to take to be a good manufacturing company and stay alive. You're going to have to do things better, faster, stronger. So computer integrated manufacturing. In manufacturing, it's not static. It's always changing, always getting better, right? Ever since they started keeping records in about 1820, productivity in our factories, in other words, the amount of work coming out per person, has always increased quite a bit. So the Japanese word for improvement is Kaizen, change, Kai, Zen, good change. And it's got everybody involved, from management on down to workers to the janitor, right? And we'll talk about that a little bit more later on. In flexible manufacturing systems, GM in the 1990s did what's called reindustrialization. They bought a bunch of robots to make specific cars. So they built this factory in Virginia to make Grand Prix and Grand Ams. And they were planning about 220,000 cars a year. Well, the economy took a dump, and they only sold 140,000. You could get a Grand Prix or Grand Am dirt cheap, and they couldn't do anything with it. That's the only car they could make in that factory. Toyota took the approach, well, we're going to make it so we can make any car on our assembly lines. So if you're, well, except for the Tundra, that's got a special factory. But if you go to like any factory, they're making cars, and the economy kind of goes down, well, not a problem. We'll just make Corollas, right? Because those are cheap cars, people will buy them. Economy goes up, so okay, good. We'll start making some Supras and Camrys, right? They can make almost any car they want on the assembly line, and they can change it over in just a matter of minutes. So you got to have flexibility, right? If you get stuck in one process without any flexibility, and for some reason customers no longer have that demand, you're screwed. You're screwed. So some of the big concepts today that we've already talked a bit about, it's just in time. It's about eliminating waste, and waste is basically any activity that the customer's not going to pay for. You got flexibility, right? And you got to have cross-trained workers. So if you have a bigger demand for Corollas, you got to have somebody that's trained to work on Corollas as well as Camrys, which is a big difference between what Whitney and Ford try to do, right? They try to make it very specialized. You just did one thing all day, right? But cross-training gives you more flexibility. Toyota production system, this is lean manufacturing. It goes beyond automotive manufacturing. It's everywhere, right? And we'll talk about the difference between lean manufacturing and mass production, and all the different strategies that go into this. And finally, lean manufacturing itself. Again, you're eliminating everything the customer's not going to pay for. And it's a system-wide look at it, not just each individual parts. So the state of manufacturing now is to make high quality, cheap, I want to say cheap, less expensive parts, and provide the customer only things he'll pay for. Okay, this is a video of that's in the assignments. Watch it. It's just a short video, but you'll see I'm going to focus a lot on this course, quite a bit on lean and also quality, because those are the two big things, lean and quality. That's what keeps factories going, keeps factories in business. The other thing I'm going to talk a little bit about is Six Sigma. What it is, it's about making things to near perfection, right? Thought is, if something breaks, it costs money to fix it, and plus it makes the customer mad. And we'll talk later on about what 3.4 defects per million, what that means. And basically, when you find something breaks, you put it to bed so it can't break again. So you eliminate the causes of defects. One of the most basic tools are the 5 Whys, and we'll cover that later on also. But Six Sigma, we'll spend some time with this also. The thing today now is not just delivering product on time, but also developing new products faster, stronger, better, right? So they got this thing called rapid prototyping. So you you can basically build any part you want in virtual space inside the computer. Um, the first airplanes that, or the airplanes that Boeing manufactures now, when they're designed, they're flown in the computer. They're flown in the computer, not in real life. And they're also flown by computers when they do the test flights, not real people. So there are some things you can do. You got these different techniques. I just saw where they took a 3D printer up to the International Space Station. So if they need a part, they don't have to wait for the next rocket to come up there. They just send up a computer file, and they make the part themselves, right? And basically, all these 4 things that you see on the slide are ways to make products using the computer, right? Work cell. Again, you want your work cell to be efficient. And again, this is part of Lean. And you arrange this in groups, right? In a smart group. If you look at this picture here, you see it's not in a straight line. It's more of a C-shaped, right? So you don't get stuck on one part of the line. You can basically go any part on this line and move quickly, right? Again, you got to have cross-trained members to do this, right? And also, you got the work envelope. We're talking about like how much you're moving, the use of robots or your machine, and by degrees of freedom, that's how many different ways you have to move. You don't want a whole lot of these. You just want it to be very simple, right? Keep it simple, stupid, the KISS principle. These are some of the references I use for this. If you want to, I'm just going to put them here if you want to look at them. Pause it and take a look. Yeah, there was quite a bit of reading for this thing. Well, actually, I just kind of skimmed over, but this is some good material. It's all very good.